Imagine a force so powerful it travels 100 million miles, yet remains potent enough to sculpt the atmospheres of worlds billions of miles further. This invisible torrent, born from our sun, is constantly reshaping our solar system. But what if its influence stretched far beyond what we ever truly understood, connecting distant giants in ways we're only just beginning to uncover? For decades, we've known about the solar wind, a stream of charged particles ejected from the sun's corona. It's responsible for Earth's auroras and the tails of comets. We understand its immediate impact on inner planets, but its reach into the frigid, distant realms of the outer solar system has always been a subject of profound mystery. Jupiter, the colossal king of our solar system, boasts a magnetosphere so vast it could swallow 1,000 Earths. This magnetic shield acts like a cosmic bouncer, deflecting the solar wind and creating spectacular auroras at its poles. The sheer scale of this interaction is mind-boggling, a constant battle between solar fury and planetary defense. Yet even with its immense magnetic field, Jupiter isn't immune. The solar wind compresses its magnetosphere, driving complex plasma dynamics within. Missions like Juno have provided unprecedented views of these interactions, revealing how solar wind energy is transferred deep into Jupiter's atmosphere, influencing its weather patterns and even its powerful storms. Now shift your gaze to Neptune, the enigmatic ice giant, nearly 3 billion miles further out. Its magnetic field is a bizarre anomaly, tilted almost 47 degrees from its rotational axis and significantly offset from its center. This creates a highly asymmetric and dynamic magnetosphere, a stark contrast to Jupiter's more ordered shield. For a long time, scientists believed that at such extreme distances, the solar wind would be too diffuse, too weak, to have a significant impact on Neptune. The prevailing thought was that Neptune's internal dynamics and its moon Triton were the primary drivers of its atmospheric and magnetospheric phenomena. The solar wind was considered a mere whisper, easily ignored. But a groundbreaking new study challenges this long-held assumption. By combining data from Voyager 2's historic flyby with advanced computational models, researchers have found something astonishing. Despite the vast distance and the solar wind's diminished intensity, it still plays a crucial active role in shaping Neptune's magnetosphere and driving its auroral activity. This research reveals that Neptune's unique magnetic field geometry makes it surprisingly susceptible to solar wind variations. Even subtle changes in the solar wind's pressure and direction can cause dramatic reconfigurations of Neptune's magnetosphere, leading to powerful bursts of energy and particle precipitation into its atmosphere. It's a dance of cosmic forces, far more intricate than we ever imagined. What does this uniting of Jupiter and Neptune truly mean? It suggests a universal principle at play. Despite their vast differences in size, composition, and magnetic field structure, both gas giants are profoundly influenced by the solar wind in ways that are fundamental to their planetary environments. It's not just about the strength of the wind, but how each planet's unique characteristics amplify or modulate its effects. This understanding isn't just academic. It has profound implications for our search for exoplanets. If solar wind interactions are so critical for planets within our own system, even at its farthest reaches, then understanding these dynamics becomes paramount for assessing the habitability and atmospheric evolution of exoplanets orbiting other stars. It helps us predict how stellar winds might strip away atmospheres or create protective shields on worlds light years away. The solar wind, this invisible breath of our sun, is not merely a local phenomenon. It is a cosmic sculptor, an architect of planetary environments, reaching across billions of miles to connect worlds in a grand, intricate ballet. It reminds us that even in the seemingly empty void, everything is connected, and the universe is always revealing deeper, more profound truths about its fundamental workings. Perhaps the greatest lesson is this: the universe is far more interconnected than our limited perspectives often allow us to see. The whispers of our sun, traveling across unimaginable distances, continue to shape the destinies of giants, reminding us that even the most distant mysteries are often tied to the most familiar forces.